Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem. And here we have n to the power of 6 minus 8 equals to 0, and we will solve this problem for the values of n. So here we find all the roots of this equation. So the very first thing we are going to do is here we first rewrite this equation as here you have n to the power of 6, and we will write it as n squared and its whole cubed, minus we write this 8 as 2 cubed, and this whole equation equals to 0. So here we need to use the nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b squared. So now we will use here this nice formula. After applying this formula, the above equation will becomes in the form of uh, n square minus 2 times of, because here you have the value of a is n square and the value of b is 2. So we put the values of a and b in this formula, and you will get its output in the form of n squared and its whole squared, and plus ab. So this is n square into 2 and plus b square, and b is 2 square, and this whole equation equals to 0. So now we make little bit simplifications here, and now first we have n squared minus 2 into now we can write this as n square and its whole squared, plus here you have 2 times of n square, and plus here you have 2 square, which is equals to 4, and this whole equation equals to 0. So here you have two cases. The first case is we write n squared minus 2 equals to 0, and the other case is we write n squared and its whole squared plus 2 times of n squared plus 4 equals to 0. So in the first case you have n squared equals to minus 2 equals to 0. So here you get n squared equals to 2, and now we need to remove this square sign, so that we will take the square root on both of the sides. So here you see that these two and square root are cancelled by each other, and we get n equals to plus minus square root of 2, because the square root of 2 will becomes square root of 2, and when we take square root on both sides we will write plus minus sign. Now we move towards this quadratic equation, and here you see that it is quadratic in n squared variable. So that now first we will make little bit simplifications here, and we will take y equals to n squared. So when you take y equals n squared, then this equation will becomes y squared plus 2 times of y plus 4 equals to 0. So it will becomes in quadratic form in y variable. So now we will use the quadratic formula in order to solve this problem. So that here we have a equals to 1, b equals to 2, and c equals to 4. And now our nice quadratic formula will be y equals to minus b plus minus b squared minus 4 times of ac square root over 2 times of a. So now we put all the values of a, b and c in this nice formula, and we get our desired results. Here we have the value of b is 2, and we get minus 2 plus minus, here you have 2 squared and its whole square root, and minus 4 times of a is 1 and c is 4, and this whole over 2. And in the next step we will write as minus 2 plus minus, here you have 2 square will becomes 4 minus 4 times of 4 will be equals to 16, and the square root over 2. So now we need more little bit simplifications here, and we will rewrite this equation as minus 2 plus minus 4 minus 16 will be equals to minus 12 whole square root over 2. And now we will take little bit simplifications here, and you get the value of y equals to minus 2 plus minus, here you have minus times of 12, and we will write it as 4 times of minus 3 and its whole square root over 2. So in the next step we can write some little bit simplifications here, and you have minus 2 plus minus, you know that the square root of 4 equals to 2, and we write the square root of minus 3 over 2. And you know that when the negative sign will becomes under the square root, then it will be equals to iota, and we write it as minus 2 plus minus 2 times of square root 3 into iota over 2. So now we take common 2 on the upside, and we write y equals to 2 into minus 1 plus minus square root 3 into iota and this whole over 2. So these two terms are gone, and here we obtain y equals to minus 1 plus minus square root of 3 iota. So here we have two cases. The first case is we write the positive term, which is minus 1 plus square root of 3 iota, and the other case is we write the negative term, which is y equals to minus 1 minus square root of 3 iota. And now we will back substitute the value of y, and in the start of the problem here we take our y equals to n squared. So now we back substitute the value of y, and it will becomes n squared equals to minus 1 plus square root of 3 iota, and similarly here you get n squared equals to minus 1 minus square root of 3 iota. And now we take again square root on both of the sides of this term, so it will be looks like in this form, and here you have these two terms are cancelled by each other, and we will get n equals to plus minus square root of minus 1 plus square root of 3 iota. So these are the other two complex roots, and now we focus on this term, and here you again take the square root on both of the sides, and you get these square are cancelled by each other, and we got here n equals to minus 1 minus square root of 3 iota. So you write plus minus sign again here. So finally we have the two complex roots are here and two complex roots are here, and our two complex roots will be right here. These are the two real roots. So this is the our total 6 roots of this problem, and this is the final answer of this problem. And I think so you will like this video, and thank you so much for watching my video, and subscribe to my channel. Bye bye.